Okay, continuing with Torricelli's law. Okay, now we had the first example to concern an upright circular cylindrical tank. Now in this example, we are looking at a spherical tank, and this tank is going to be filled with water, and the tank has a radius of 2 feet, and we have, once again, just like the cylindrical tank, okay, we have at the bottom of this spherical tank, we have a 1-inch hole that is cut out. That is a 1-inch radius hole to be cut out. And we have posed the question, how long will it take for this tank to empty? Okay, so in terms of setting things up, so just go ahead and put in the representation of the spherical tank itself. Again, the tank itself is going to have a radius of 2 feet. I'm just going to put a couple of marks here. So you have a radius of 2 feet. And for what we have in terms of the liquid itself, now we can have the liquid level either above or right at the middle, that is the middle of the tank, or just below. And we'll say that just for the markings here. We'll say that for what we have here. Okay, now for the liquid level, again, this is going to be at Y. As was the case with the circular cylinder. And what I'm going to do here, just kind of doing a little bit of modeling and just sort of taking what we have here. And I'm going to sort of do a bit of a projection. I think what I'll do here is just copy what I have over here and just kind of give you a little bit of an extrapolation in terms of setting up what we have for establishing the cross-sectional area, as well as everything else that we have in the follow-through. Okay, so if I just form a bit of a triangle, okay, so we got establishing a right triangle. And I'm going to apply the Pythagorean equation. Okay, and for the three sides here, okay, so the hypotenuse is going to be the radius of the sphere. And for what we have at the liquid level, okay, again, that is going to be R. So R is going to be the radius of the liquid. And since I have it positioned where the middle of the tank is above, okay, the liquid level, and say that the difference between the middle section of the tank and where the liquid level is, we'll just say that is going to be 2 minus y. But if the liquid level happened to be above, we would have y minus 2. Okay, but you're still going to have the same general setup for the radius of the liquid itself. So looking at this particular right triangle, okay, so again, so you got 2r and 2 minus y, and setting up what we have here, okay, and expressing in terms of the radius of the liquid. So looking at the Pythagorean equation, so we have the square of the radius plus the square of 2 minus y is equal to the square of the hypotenuse being the radius of the spherical tank. Okay, so just following through. Okay, so you have r squared plus 4 minus 4y plus y squared is equal to 4. And if you notice, okay, we're going to have 4's to cancel out. And when we isolate the radius, or the square of the radius, okay, so you have r squared is going to be equal to 4y minus y squared. And since we are interested in just a positive measure, r is going to be equal to the positive square root of 4y minus y squared. Okay, and looking at the establishment of the cross-sectional area. So just looking at, once again, an overhead view. So you can say that for the black circle, okay, that is going to be for once again the spherical tank, whereas the blue circle, that's going to be in reference to the inside liquid. Okay, in this case, water. And so we have just for the inside radius, the radius of the liquid. So you have 4y minus y squared, his square root. Okay, so you have the radius. And for the cross-sectional area of the liquid itself, so again, we're looking at pi r squared. And that's going to be equal to pi times the square of the square root of 4y minus y squared. So the cross-sectional area here is going to be pi times the quantity of 4y minus y squared. Okay, so we have with our articles at hand. Okay, so we've got pi times the quantity. Okay, so you got 4y minus y squared dy over dt. Okay, and just for the area of the hole itself, now let's go ahead and mention. Okay, so you have for the hole, again, you have pi times the square of 1 inch, or the square of 1/12 of a foot. So you have that bit of history to repeat. All right, so just filling in. Okay, so we got the negative pi over 144. And since we are, again, dealing with the English units, okay, now we're going to have this bit of history to repeat since I'm looking at the same size whole. Okay, and here we got square root of 64, which is 8. 8 over 144 is going to be 1 over 18. And I can go ahead and get the pi's to cancel out. And so just taking what we have now, so we've got 4y minus y squared dy over dt. Again, it's going to be equal to negative 1/18 of the square root of y, and once again multiplying by negative 18. So we're going to have negative 72y plus 18y squared dy over dt is equal to the square root of y. Okay, now if I'm dividing by the square root of y and multiplying by dt simultaneously, okay, and just look at this now, negative 72 y to the first divided by y to the 1/2, that is going to leave negative 72 times y to the 1/2. And for 18y squared divided by y to the 1/2 is going to be y to the 2 minus 1/2. So we're going to have 18y to the 3/2. So we have this portion dy, and we have equal to dt. And looking at integrating over both sides. Okay, so in this particular case, for y to the 1/2, antiderivative is 2/3 of y to the 3/2, and multiply by negative 72, so we have negative 48 y to the 3/2, and for 18 times, well, it's going to be 2/5, we have 7.2 times y to the 5/2, and to the right we have t plus c. Okay, now whenever the tank was full, again going back, okay, now the initial liquid level is going to be the diameter of the tank itself. So we have y naught is equal to 4. So we have, filling in, we have negative 48 times 4 to the 3/2 plus 7.2 times 4 raised to the 5/2. Okay, and that's equal to 0 plus c. And for the value of the constant, okay, that's going to be about minus 153.6. So for what we're going to have in the case of the formula itself, so I have negative 48y to the 3/2 plus 7.2 times y to the 5/2 is equal to t minus 153.6. Okay, and so whenever the tank is empty, we have that y of t is equal to 0. And so ultimately what's going to happen here is that for applying 0 for y, okay, so we have for these values, also we're going to have that 0 is equal to t minus 153.6. And in terms of how long it's going to take, for the tank to be emptied, given our conditions, so it's going to turn out that t is equal to 153.6 seconds, or about 2 minutes and 34 seconds.